This presentation is on angle beam inspection of structural steel welds using AWS D1.1 code. The code limits the inspection to thickness over 5/16 of an inch and requires the use of very specific transducers and calibration hole. So this inspection is actually quite straightforward, but it does require very specific steps to be followed to perform the inspection. So I will go through each one of the steps one by one and describe how the inspection is conducted, and then go into the acceptance criteria for this inspection. Okay, we start the inspection. Firstly, we have to get all the equipment to do the inspection. The pulsar receiver for this inspection is the normal UT machine, and the second thing would be the ultrasonic probe. The probe requirement as per AWS D1.1 is a 2.25 megahertz frequency probe. The size 5/8 inch by 5/8 inch, or a slightly higher size as per AWS D1.1, but probes like 1/4 inch and 1/2 inch are not acceptable for this inspection. Now we have to figure out the refracted angle of the probe. The refracted angle to be used depends on the thickness of the steel to be inspected, and that is given in table 6.2 of AWS D1.1. Once we have all the equipment to do the inspection, then we need a IIW block and to establish the calibration sensitivity. The calibration sensitivity is established on that 0.06 inch hole. The signal from the hole, which is the 0.60 inch hole, is set to 50% screen height, full screen height, and the gain is noted, and this is called the gain B. Then we start scanning the structure, and then let's say we find an indication while we are scanning it, and here we are doing the inspection, and this is the indication in purple color, and same probe, 70-degree probe, and then again we adjust the signal from this indication to 50%, and in this case this is called gain indication rating A, which is actually 66 dB, for example. So now what we have is, we have the gain B from the IIW block, which is the calibration sensitivity, and then we have the gain A, which is called the indication rating, and that's from the weld being inspected, and let's assume that is 66 dBs. Now when we find the indication, we also measure the metal pad C to calculate the attenuation factor, which is C. So the attenuation factor C is given by 2 times metal path minus 1. So let's assume the metal path is 2 inches, so 2 times 2 minus 1 equals to 2. Now using the A, B and C, then we calculate D, and D equals to A minus B minus C. So in this case, A equals to 66 dB on the indication, B equals to 58 dBs on the 0.06 inch hole, and C is the attenuation factor, which is equal to 2. So A minus B minus C, which is 66 minus 58 minus 2, equals to plus 6 dB. Once we calculate that number, then we go to table 6.2 of AWS D1.1 to determine the class of the indication and to find if it is acceptable or rejectable. So now let's go to table 6.2 of AWS D1.1. So in the indication we detected, our indication rating D was equal to plus 6 dB. So now, since the thickness of our member was 1/2 inch in the last figure we saw, so we go to this column, and plus 6 dB corresponds to a class B indication. Now we have to go to the next slide to find out if class B is acceptable or rejectable. So let's go to the next slide, and in the next slide indication. Class B is a medium indication, which means that any indication having a size that exceeds 3/4 of an inch shall be rejected. So that's how the AWS D1.1 is done. So just to summarize the whole inspection, first we measure B, which is on the IIW block, 0.060 inch hole. Then A is measured on the indication in the structure being inspected, and C is measured from the metal path, which is 2 times metal path minus 1, and then we calculate D. And once that is done, then we go to table 6.2 for statically loaded structures and table 6.3 for dynamically loaded structures, and then find the classes of indication and see if it is acceptable or rejectable. If you want training in AWS D1.1 UT inspection, please give us a call and you can get the full practical training at our training center.